Okay, so hopefully this makes sense. This is, so the showcase is timed. So you can go to the D2L quizzes and, you know, open it up, don't hit start, and you'll see these directions here there. So if you lose this paper, it's also posted in the showcases module. But the minute you click start, you have 1 hour, so make sure you are prepared, okay? So when you click start, you will see short directions, and then you will have a choice of 3 problems, similar to these angle of elevations that you did today, and in some of them in your day 4 homework, okay? And so you have to make the choice which one you're gonna do. Maybe you work 2 of them and see which one you think's better. It's up to you, but you have an hour, which I think will be plenty of time, okay? Then you have to make a video where you explain it. So here's where the video might be different than the picture video you did in the practice. Somehow you either have to show your finger or your pointer, your cursor on your mouse or something. Because if you just stand and talk with that written, I have no clue what's going on, okay? The point is that you can explain it, not just regurgitate equations, because I have people just memorize the format. You need to be able to explain why you did what you did, okay? So if you want, then, you know, you can write it on your paper, then put your paper either on your computer or in front of your camera. So if you were holding your cell phone, maybe if you could find some way to, I don't know if you can do it both. What I recommend you do is maybe do a practice problem on your own, just choose one and do it, and get the logistics down. Is explain it. If you would prefer to just write as you're doing it, that's fine too. Or write part of it as you're explaining it, like I do in class, but you do not have to. Okay, you could simply point and say, you know, I need to find this, so I chose 72, so I did opposite over adjacent, so I got an equation that can help me find D, you know what I mean? Okay? You do not have to show your face, don't care about that, all right? Then once you are done with your video, you upload it, and you're done. Okay, Dan, I think you had a question.
You answered it.
Oh, I did? Okay, oh, that was lucky. Okay, anybody else? Yeah,
So,
Georgia.
the, like, 1% after minute, like, how do you, are like, am I up till, like, am I supposed to keep track of, like,
No.
how long it is? Or-
No, I mean, I think there's a timer on those quizzes, isn't
Okay.
there?
Yeah.
I think
Yeah.
there's a timer.
I just didn't know if it would let you, exceed that.
Probably, yes.
Okay, would they, like, give you some kind of notification or something like that?
Oh, with the, on the quiz.
I don't
things,
remember, I have
has,
to
like
look.
a timer thing
Okay.
at the top that goes
Cool.
through, and then it like blinks at like, you have 10 minutes left, and then blinks at like you have 5 minutes left.
I've never set a timer very often. I don't use that quiz tool very often, because, you know, we have my math lab.
Right.
So, so it does show the time
Mhm.
at the top, and it blinks when it's getting close.
Yeah.
Okay, okay, that's good. The timer is good to know.
You can submit,
Oh, go ahead.
you can submit if you can go after or beyond it and submit it, it'll just tell you in red, hey, you went over this many seconds or this many minutes.
Yeah, yeah, I'm pretty sure you can go over.
Yeah.
Yeah, thank you, Bree. Cameron?
So, the process is that you open the quiz and it'll give you questions and then you solve it on your own time and then take a video of.
No, you solve it within that hour.
Like, would you be taking a video of you solving it, or would you solve it before and then take a video of?
You solve, so it opens up, you have 3 questions, you choose what question you're gonna do, you solve it on your paper, the timer is running. You solve it on your paper, you make the video explaining it, you upload the video within an hour. So you don't look at the questions, then like a day later make the video. You have that 1 hour to see the question, choose a question, solve the problem, explain it in your video, post the video. Does that make sense? Okay, good. Dan?
Well, I use the UJA
Yeah.
platform for my practice showcase.
Did it
And I
take a while?
noticed that it takes a significant amount of time to upload the video.
Yeah.
So I would actually, using that, have maybe 45, 50 minutes for the problem and then hope that it
Yeah.
uploads in time.
Yeah. So if that happens, you just shoot me an email. I don't think, or if you could type a message in, say I used UJA, it was slow, then I know. it's fine, I get it, yeah, that thing, I can't believe the school spent so much money on that. to be
Try a
honest.
Screen-O-Matic one, that was pretty good.
What was it?
The
Screencast-O-Matic.
Screen.
Oh, Screencast-O-Matic, the free
Yeah,
one.
that one was
Free.
pretty good.
Do you know, is there a file size limit for how big
Oh,
you make your video
yes.
file?
There was,
It
yeah, that
compresses
was a
it.
whole thing with my practice showcase. I had to slow down the quality or whatever to try and get it to fix. I think it was like 100
100 megabytes.
Yeah, something like that
100
was the
megabytes.
thing, and so I had to.
And that was on which one?
The practice showcase.
On which video thing were you using?
I was using iMovie.
iMovie.
Okay, that probably is not compressed though.
Yeah.
Screencast-O-Matic, because you're not paying for it, they just give you the compressed crappy version. So you're not getting like 4K.
But to be honest, we teachers, we use
Yeah,
Screencast-O-Matic
it's
all the
fine.
time, and we do long, if you pay for it, you get more than 15 minutes or whatever. The free version's up to 15 minutes. People use it all the time and post those videos for students. So I don't think it should be a problem.
With iMovie, like,
If you
trying
do
to adjust all the
Screencast-O-Matic.
things.
Okay. Or you could upload it to YouTube and put the link. So these are things to be thinking about. You have plenty of time because it's not due till after the first assessment. So if you're having issues with the video thing, maybe do a trial run. Come talk to me, we'll work it out. We can find someone else maybe that's better at it. But unfortunately, we don't have a lot of time to go through all of these questions. So maybe think about it, try some things, and then come see me, or email me a question and I can put it out there to the class, but, okay, is that cool? Okay.
Could we like send like kind of a trial to the practice showcase thing? Cause I think it was like still, or maybe it's fully closed now, but like just
No,
to
it's not.
like double
I don't
check.
think it is.
Like if it's like trying a new thing and seeing like, does this work well?
Oh, yeah,
Or like seeing
yeah.
how long it takes to upload.
sure, that'd be fine.
Cool.
Okay, so, how about your day 4 homework, those applications? How are you doing on that? It was supposedly closing today at 1, correct? How many people need more time?
Is that MML?
My math lab. Yeah, day 4 homework in my math lab. How many people need, be honest, I don't care. You need more time? If you didn't get it done? Okay, I'm gonna give more time if you need it. Okay, so I'll extend it through the rest of the week, okay? Because those are important that you get through it. And I do realize it's long. So if you have questions, come see me, email me. We can do another angle of elevation thing on Monday, which is part of Monday is our review day for the assessment. Okay? The one thing I don't have to shine up here, but I will have it posted, is talking about the first assessment. So I'm just going to have to post it in D2L, and I'll put it in the announcement, and you can read about it. But here's my comment, because what we're going through today. There is, the assessment has like 7 questions. It's short, because we only do it in an hour. Okay, hour 15 maybe. But part of the assessment is no calculator, and part is calculator. And I'll tell you as we're going through what things will be on the no calculator so that you're preparing without using your calculator. And most of our assessments will be part no calculator, part calculator. Because there's so much in this class that you need to just know without your calculator when you get to calculus. So we want you practicing it. Most of it is based on the unit circle, which is where we're going to go now. Okay? So make sure, if it says use the unit circle, use the unit circle. Do not use your calculator because you're going to be in trouble on the assessment when you don't have one. Okay? Okay. So let's go to, did I start this? Oh, I did. Haha. Okay, so I just need to minimize. All right, so day 5 activity, I posted the entire thing. So I don't know, we tried to get through page 7, okay? Try to get through page 7. I'm going to come back and hit some of these topics. Oh, this is one we didn't talk about. So number 9, I don't know the page. I gotta find mine. So this is day 5 from Monday. Okay, this is what is happening in this part right here is super duper important. and is gonna be your lifeline, knowing this, going forward in this class. Okay? So what's happening here? We're now saying our trig function values can be positive or negative, right? Because those are based on the x coordinate and the y coordinate of the point on the terminal side. Okay? So you've got to get a way of figuring out, if you say, I have an angle that terminates in quadrant 3 and I want to know its secant, is that value going to be positive or negative? Or its sine, is that value going to be positive or negative in quadrant 2? And we need a quick way of doing it. Okay? So what did we say on Monday that was helpful? I think we said that, remember the x goes with cosine and y goes with sine, right? R is always positive, okay? So the trig functions that depend on y, well, sine just depends on y, and r is positive. So if y is negative, sine is negative. If y is positive, sine is positive. Okay? If cosine, it's going to depend on if the x coordinate's positive or negative in that quadrant. If cosine's positive, or sorry, if x is positive, cosine's positive. If x is negative, cosine's negative. And then look at tangent. Tangent depends on y and x. So if x and y, did you fill these in? Okay, so if x and y in quadrant 2, x is negative and y is positive. So notice these two signs are different, right? And that's in quadrant 2, x and y have different signs. And in quadrant 4, x and y have different signs. Okay, so this is what I like to remember is tangent is going to be negative in quadrants
2 and 4.
2 and 4. Notice how they're opposite of each other. 180 degrees apart. Pi units, okay? Tangent is positive in quadrant 1 and 3. Okay? So notice how they're opposite of each other. Okay? So what does that tell me then, for example, about the reciprocal functions? What function is the reciprocal of sine? These you gotta know. Cosecant. Cosecant theta. What function is the reciprocal of cosine? Secant. These are things you gotta get together in your head. What function is the reciprocal of tangent? Cotangent, okay? So how do I know if these are positive or negative?
Based on if their reciprocal is positive.
Yeah, the reciprocal. So if you know, I call them the big three. Sine, cosine, tangent, you know those. You can always figure these out because they're reciprocals. And they will have the same SIGN as sine, SIGN. So if sine is positive, cosecant's positive. Cosine's positive, secant's positive. Tangent's positive, cotangent's positive. And that's true in the other quadrants. They'll be the same as their reciprocal. Cool with that? So that's pretty sweet. You just, if you know the reciprocal, you're good. Okay? So getting these in your head based on the x and y coordinate. Okay? We're gonna use that quite a bit. So let's get to, did you guys get to 11 and 12? Is this page 7?
Yes.
Yep.
Do you want to talk about any of this stuff here, 11 and 12? Because that is going to come into play, I believe, in the next section. The reference angle and the trig function values. How many people want to talk about 11? Give me a hand raise so I know. Okay, how many people did number 12? I just want to see that. Okay, all right, let's go through this real quick. So what is the sine of 60 degrees? If you don't know now, you go back to your table and question number, I don't know the number, 2 or 3. Page whatever. Anybody got it for me? Top of page 2. Okay, if you're going to learn it fast, we're going to get it. So the sine of 60 degrees is root 3 over 2, okay? The tangent of 60 degrees is basically, it's the sine of 60 over the cosine of 60, right? Tangent is sine over cosine. So sine of 60 is root 3 over 2. Cosine of 60 is 1/2. That simplifies, right? We get rid of the 2's. That simplifies to root 3. Okay? So we want to know what's the sine of negative 240 and the tangent of negative 240. So negative 240 lies in quadrant 2. In quadrant 2, sine is positive or negative? Quadrant 2. Sine is which letter?
Why?
Why? Because I want to know. Sorry. Tangent is which letters?
Oh.
What?
Y over x. Okay? So keep that in mind. So sine is positive. In quadrant 2, tangent is
Negative.
negative because these are opposites. Negative, okay? So what does that tell me? The sine of negative 240 is going to be is going to have the same value as the sine of 60, its reference angle, because yeah, I won't go there, okay? But they're going to be different by a positive or a negative, possibly, okay? So it's going to be root 3 over 2, and it's going to be positive, so we don't have to change it, okay? Tangent is going to be the same as the tangent of 60, so it's going to be root 3, but is tangent positive or negative in quadrant 2?
Negative.
Negative, so you have to add the negative. But you use those basic sine, cosine, tangent values of 30, 45, and 60, and you can find trig function values of lots of other angles that have that reference angle. So you don't have to remember as much as you think you do. Questions? Does that make sense? So why do you think we've been practicing this reference angle thing for so long? This is where we use it. So here's the thing. 675. First thing I need to know is what quadrant is it in. So you tell me, how are you going to decide what quadrant that angle terminates in? So here's my initial side. It's going to rotate in the positive direction. Where's the terminal side going to land? Quadrant 4. Okay, how'd you do that? You subtract 360, get rid of the full rotations. What's that going to be? 315? Okay, that's why we said find the least positive angle coterminal, because that's where we decide the quadrant. Good job. So we're going to go, whoops, I went a little far, sorry. Okay, so now I need to know, what is this distance here? What is the reference angle? How many?
360 minus 315.
360 would be a full rotation minus 315, which is basically, I don't know, I get too much on here. This angle is 315. If that makes sense. Okay? Yeah. So remember, it's acute between 0 and 90, and it's always positive. I don't even put an arrow on my reference angle because I don't care about a direction. It's just a distance. Okay? You can. All right? So this would be my theta prime if my theta is this 675. Okay, so it's how much? 45. Okay, so what does that tell me? The sine of positive 675 is going to have the same value as the sine of 45, but I have to decide here if it's positive or negative. The cosine of 675 is going to be the same as the cosine of 45, but is it going to be positive or negative? Do not use your calculator on these things, because this is something where you won't have a calculator, and no, we won't make huge numbers. But the idea is you're using these values of the reference angles that you have memorized. Okay, what quadrant are we in? We're in quadrant 4. In quadrant 4, is sine positive or negative?
Negative.
Negative, because sine is the y coordinate. You're going down. Cosine is the x coordinate. You're going to the right, so it is positive. And then you just insert those values. So this is going to be negative root 2 over 2, and this is going to be positive. You don't have to write that. I just was in mid-stroke. Okay? Okay, so going to have to get a way of remembering that chart and those values, and then deciding the positive, negative. The reference angle and that coterminal angle thing, that's all old. We've been practicing, so now you don't have as much stuff to put together, just 2 new ideas. Questions? Okay. Okay, so actually, let's take our break now because I don't want to get into this and have to stop. So, hold on. Right. So you see you get the same value, right? Okay, so where is that? 1/2. So my y coordinate is 1/2. So that means I'm going to go on my y-axis to 1/2. And I have 2 points. I've got a point over here in quadrant 1, and I've got a point over here in quadrant 2. Sorry, it's very crowded. So this point is going to be, these both have a y coordinate of 1/2, and what one x coordinate was positive root 3 over 2, right? We go right and then up. So this one was negative root 3 over 2. Okay? So we can see that we have symmetry, we could fill all those points in. The key thing here is, what are these angles? If I have an angle in standard position and its terminal side moves and stops so that it goes through that point, what is that angle? It stops and goes through that point. What is that angle starting here on the positive x-axis, right? So if the terminal side passes through those points, what is the angle? Okay? So what I would like you to do then is see if you can walk through this page. So we're trying to figure out you're going to label the x and the y and the r, okay? And then you're going to do your old definition. Remember your old definition? The one old, as in Monday, right? Cosine is x over r. Sine is y over r. Okay? So you label the values on your triangle. What's r going to be if this is a unit circle? R is always going to be 1. So you just have to label those sides, and then you don't have to label them, but you use those values. Or you could even think of SOHCAHTOA a little bit too, couldn't you? Or whatever you call it. Okay? So find those cosine values, determine the angle, write the angle in degrees and radians. Okay? Write the angle in degrees and radians. So you're just using the x coordinate, the y coordinate, and the r value and setting up those ratios, and what are you getting? Tiny trig function.
Right. Oh, okay, all right, thank you.
Okay, so in this part A, you should get cosine of that angle is root 3 over 2, sine is 1/2. So if you looked in that table on page 2, what angle has a cosine of root 3 over 2 and a sine of 1/2? You need to look back at your table.
Are we gonna have to memorize the table then?
Well, we're going to show you a way to get to it. So if you want to memorize the table to help you with this, you can, or you can go the other way. So what angle has a cosine of root 3 over 2? 30 degrees. Or in radians is pi over 6. Okay? So what's that telling me? This angle is 30 degrees. Okay? So what do you notice? The x coordinate of that point is the value of the cosine of that angle, isn't it? Okay? And the reason it's the value is because it's a circle of radius 1. If that circle had a different radius, then that point would not be the exact value because we'd be dividing by some other r value. Okay? So that's the cool thing, is that's why cosine goes with x if you're talking about a unit circle. Okay? The y coordinate is 1/2. That is the sine of 30 degrees. Y goes with sine. Okay, see those connections? Okay, so what happens here? So this is going to, cosine is going to be root 2 over 2. Sine is root 2 over 2. This is x over y, or x and y. They're always over 1 because that's a circle of radius 1. So root 2 over 2 over 1 is going to be root 2 over 2. Y over r, root 2 over 2 over 1 is also root 2 over 2. What angle has a sine and cosine that are the same and are both root 2 over 2? 45 degrees. Or radians is pi over, how are you going to remember it? Pi over 4. Okay? And I heard pi over 2. What would pi over 2 be? Because pi is how much? 180. So if I divide both sides by 2, these are just helping you remember these things. If I divide both sides by 2, I get pi over 2 is 90. Okay? So the 90, the quadrantal angles are going to be multiples of pi over 2 or multiples of whole pi's. Okay? All right? So this angle is 45. Okay? So last one. Now look at the first one and the last one. What's the only difference in these coordinates?
You're switched.
They're switched, aren't they? Same values. There's a 1/2 and a root 3 over 2. They're just switched. Okay? So what's this one going to be? This is x, this is y. So 1/2 over 1 is 1/2. Y over r, 3 over 2 over 1 is root 3 over 2. Okay? What angle has a cosine of 1/2 and a sine of root 3 over 2? 60. So 60 degrees, or how are you going to remember this? Pi over 3. So here's how I remember. These are different, right? 60 degrees goes with pi over 3. 30 degrees goes with pi over 6. And those are the ones that are easiest to confuse. So we'll try to show you a way to keep those straight, okay? So if, this is the idea, if you can remember everything in quadrant, oops, that's 60, sorry. If you can remember everything in quadrant 1 and the quadrantal angles, you're home free. Because then all you have to use is reference angles and symmetry. Okay? So you just have to remember your quadrant 1. So we're going to put all of those in the same quadrant, kind of like we did back here, right? Look at, we had all of those there. Now all we have to do is associate angles with those, that terminal sides of angles that go through those points. Okay? And you, this next page, oh wait, let's go back down to here. So what is the relationship between the trig function value of the angle and the coordinates of the point on the terminal side?
Sine is equal to y. Then
Okay, y, the y coordinate is the sine of the angle. Yeah, okay, what else, Jack? You said the other one.
x is equal to the cosine.
And x is the cosine. So technically, every point on the unit circle, its ordered pair gives me the cosine of the angle and the sine of the angle. Okay, so if you can generate the unit circle or remember it, you'll see patterns, and that's how you're going to remember it. Okay, so then if I know sine, cosine, and sine, can I find tangent? Can I find secant? Cosecant? Right? So all you got to do is know those two things to find everybody else. Knowing tangent without having to find it all the time is helpful. Okay, so let's go here and we'll just have you do a little bit of it. We need to get moving on too, but let's talk about this circle. Okay, so do you remember seeing those circles on day 2 or something? It was, one of them had the 30s and the 60s, and the other one had the 45s. Okay, so we're just putting them together. Okay, so let's just start and let's do quadrant 1, and then you can fill in the others with symmetry. Okay, so if I start here, I start at an angle of 0 degrees, which is 0 radians. So we're going to put both measures on each angle. Okay, so if my terminal side is here, my initial and terminal side is here, then I've got an angle of 0 or 0 radians, 0 degrees or 0 radians. Okay, what are the coordinates of that point? You're starting here and you're going here. You went how far? 1. Did you go up or down? No. Okay. Now the terminal side is going to move, tick up. Okay. So now my terminal side is here, bless you, and goes through this point. Okay. So what is this angle, this distance, do you think?
30.
30. So it's going to be 30 degrees. Oops, I'm changing my, I want to change my colors because I want to show you something. So this is going to be 30 degrees, which is how many radians? Pi over 6. Okay. So the terminal side here, not very good at that. All right. So what are the coordinates of this point? How are you going to remember which one is which? Okay. Think about what we just did a minute ago. We went we go to the right, and then we go up. Which distance is bigger? This one, the horizontal, or the vertical? The horizontal. So which number is bigger? Square root of 3 over 2 or 1/2? Square root of 3 over 2, right? Because square root of 1 is 1, so that's bigger. So the bigger one is going to be the longer distance, if that helps you, those triangles you just saw. Okay? So this is going to be root 3 over 2, 1/2. Okay? All right. Then we're going to go to terminal side ticks up to here. If this is my I'm going to have to use the same color, sorry. If this is my terminal side, what is the angle associated with that terminal side.
45.
So think about, this is 90 degrees, yes? We are halfway. What's half of 90? 45. So this is 45 degrees or pi over 4. What are the coordinates of this point? Meaning the x coordinate is the cosine, root 2 over 2. The y coordinate is the sine, root 2 over 2. Okay. All right, now we're going to tick up. This is the terminal side here. What's that angle going to be?
60.
60, which is pi over 3. Okay, what are the coordinates of that point? They're just reversed of this, right? Because 30 and 60 are complementary. Okay, so those are going to be switched. We saw that on that activity with the triangles that day when you measured. I can't get out of this mode. Okay, all right. So this is 1/2 root 3 over 2. Okay, all right. Then we get up here. I should have just left that one black. Maybe that would be better. Okay, we get up here. What angle are we at here? 90. So 90 and pi over 2. Okay, so what are the coordinates of this point? What's the x coordinate? 0. The y coordinate? 1. So that means that the cosine of pi over 2 is 0. The sine of pi over 2 is 1. Okay? So look what happens when I go into the other quadrant. Okay? Let's talk reference angles. The angle in quadrant 2, whose reference angle is 30 degrees, would have this terminal side. And I'm talking about this full angle here. Okay? This is the reference. I'm just showing you the reference angle idea real quick. If this is 30. So what's this angle in standard position whose reference angle is 30 in quadrant 2? And maybe we should go all the way around. What's this angle going to be? This is going to be 180 or pi. And this is -10. I should have done these first, sorry. I wasn't paying attention. So this is going to be 1 pi over 2, 2 pi over 2, 3 pi over 2. So the 90 degrees or pi over 2s, you can just count. Remember when we did that? It's been a while. Okay, so what are the coordinates of this point? 0, -1. Okay, so reference angle. What's 180 minus 30? 150. So this is 150 degrees or, ooh, do you remember how to do this? This is pi over 6. 5. Okay, how'd you get that? Who was that? Austin?
Yeah.
How'd you get that?
I just counted.
Okay, I like that. You counted,
Yeah, I counted five total.
so
6,
1 pi over 6, 2
2
pi over 6,
Yeah,
3, 4, 5.
Yeah.
Anybody do it different?
I mean, you could do like 6 pi over 6 minus 1.
Yeah, you did 180 minus 30 to get 150, didn't you? What's 180?
Pi.
Pi. What's pi minus pi over 6? And Jack, why did you say 6 pi over 6?
Get a common denominator.
Common denominator. This is 1 pi, 1 whole is 6 out of 6. So all you have to do is get common denominators with those radian measures and fractions. So that becomes 5 pi over 6. So I don't care how you remember it, but this is, I like this because it kind of shows a pattern here. So pi is 6 pi over 6, so it's 1 less, isn't it? 5 is 1 less than 6. Okay, so what do you think this angle is gonna be? Oh, I'm off on my colors, dang it. What's this angle in the middle gonna be? With the reference angle of 45 degrees in quadrant 2. It's gonna be how much? 135? 180 minus 45? So let's think of the pi thing. 1 whole pi is 3 pi over 3. Oh, sorry. 1 whole pi is 4 pi over 4, right? So 4 pi over 4 minus 1 pi over 4 is 3 pi over 4. So do you see how it's 1 less than the denominator? The numerator is 1 less than the denominator. It gets a little messy when I start drawing all that stuff. That's why I'm doing the colors, thinking that will help you. Okay. So this one's going to be a 60-degree reference angle. So 180 minus 60 is 120. Pi is going to be 3 pi over 3 minus 1 pi over 3 is going to be 2 pi over 3. So in quadrant 2, the numerator is 1 less than the denominator. So I'm just trying to show you patterns. You don't have to remember it like this. You have to figure out a way for yourself to remember it. Because first thing you're going to do on the assessment next Wednesday is fill that thing in blank from scratch. So you want to have a way of doing it and practice. I'll give you a blank one, but I'll post a blank one and you can practice as much as you need. Okay? So let me ask you this. Are you comfortable filling these points in now? So do I really need to do those? Okay, good. I'm just going to write this one just for a check. Just write one of them. So in quadrant 2, x is negative, y is positive. Okay. Should we finish labeling the angles? Or do you have them labeled already? I don't know. I can't tell. Okay, let's go here. So this one's going to be, let's do the pies. Oh, Debbie. Ugh. I need to just color them right now, so I don't have to. Missing these. So here's all, these 4 angles all have a reference angle of 30 degrees or pi over 6. So they're all going to be a pi over 6 multiple, aren't they? They're going to all have a pi over 6. That's what's cool about the radians. You don't have to work hard to know the reference angle. It's in the denominator. Love them. You're going to love them. Trust me. You will. I'll win you over. Just because of the niceness of it. Okay, so what's this going to be? How many pi over 6 is it going to be over here?
7.
It's going to be, yeah, this is 6 pi over 6 plus 1 is going to be 7. Awesome. Now, the bad thing is I didn't get all the way around here. So we're back at, let me put those above, okay? So if I get back from 270, I'm back at 360 or 2 pi. Okay, so now this angle here is going to have a reference angle of pi over 6. So 2 pi is how many pi over 6? 2 wholes. 2 is equal to 12 pi over 6, right? Double the denominator. That's all you got to do. That's 2 pi, 12 pi over 6. So it's 12 pi over 6 minus 1 pi over 6 is going to be 11 pi over 6. So in quadrant 3, the numerator is 1 bigger than the denominator. In quadrant 4, the numerator is 1 less than double the denominator. There are patterns. That will be true with all of the pi's. And you can use that pattern as you, oh shoot, it didn't change. Whoop. Whoop. Okay, so I know this is going to be a pi over 4, and I know this is going to be a pi over 4, but I don't know how many pi over 4s. So what do you think here? 5 pi over 4, right? 1, ooh. Oh man. Okay, here we go. This is a pi over 4, and it's going to be 5, right? It's 1 more than pi, which would be 4 pi over 4. Plus 1 pi over 4 is 5 pi over 4. What's this one going to be? What's double 4? 8. So 2 pi is 8 pi over 4 minus 1 pi over 4. We're at 7 pi over 4. Numerator is 1 more than double the denominator. I have a little graphic for that. I'll post it so you can see it, okay? All right, what about the green one? The green's going to be a multiple of what pi? Pi over 3. Yep, they're going to be pi over 3s. Pi over 3s are closest to the y-axis. Pi over 6 are closest to the x-axis. That helps. All right, so what's this top going to be? 1 more than the denominator. 4. What's this top going to be?
5.
It's going to be double the denominator minus 1. Double 3 is 6. 6 minus 1 is 5. Okay? So just trying to help you. Then you can fill in the points using, I know that the pi over 4s are all root 2 over 2, root 2 over 2 for sine and cosine. But in quadrant 3, they're both negative. Okay? So you can fill the rest of that in, but here's what happens. I've had students fill it in wrong in class and then use the wrong one, and that was bad. Or not wrong, but maybe miss a sign. So I'm going to give you the official real version for you to use as you're practicing. The back side is blank, so if you want to practice on your own, okay? But the other side is filled in perfectly. So that's what I want you to use when you're actually doing these examples.
That's true. You want?
Maybe the color, so you can find it amongst the sea of white. Which could get real crazy. Okay, anybody else? Did I miss anybody? Okay. All right, so what's going to be helpful with this? We can give this sine, cosine, tangent, secant, cosecant, cotangent of any angle on that unit circle by using the x and y coordinates. Okay? We can also find other angles that are coterminal with those angles. So if there's an angle that would land on one of those lines or pass through one of those points, it will have the same function values. Okay? So, I don't know. I don't know that this one, I think moving down to the next part is probably more important, and then you could go back and fill this in. So if you're going to fill this in, if I have my angle, the sine, we're looking at the, which coordinate? The y coordinate. If we're looking at the cosine, we want the x coordinate. If we're looking at the tangent, we want y over x. If I want cosecant, what do? I flip the sign, right? You can write 1 over y if you want. I just think if I know the sign, I reciprocate it, or it's 1 over. If I want the secant, I can write it here, but you can just flip it, especially if it's a fraction. Secant is the reciprocal of cosine, so it's 1 over the cosine value, or 1 over the x value, or the reciprocal of the x. Cotangent would be x over y, or you could know the tangent and reciprocate it. It's up to you. I personally always use x over y and y over x for tangent. I never reciprocate tangent. I don't know why, but that's, you got to get comfortable with what works for you. So you could practice filling those in. Okay, those are basic. Let's do some. Oops. Sorry. Okay, man your unit circles, and let's do some that are not. Oh wait, maybe we should do some of those. Shoot, sorry. don't know, pick a row, I don't care. I don't want you to do them all, I want you to just do a couple. So how about, you wanna do, why don't you do pi and do pi over 6, oh no, sorry, pi over 3. Pi over 3, and then do pi over 6. Why don't you do the last 3 rows? How about that? That'll give you a variety, I think, sort of. Maybe we're missing one of the main ones, but that's okay. So you're using your unit circle to fill those values in. So the sine of pi over 3 is the y coordinate of the point at pi over 3, which is, I believe, root 3 over 2. Do not touch your calculator. I don't want to see one calculator out. Put them away. You should be able to do this with only the unit circle. This is what you're going to do on the assessments without your calculator. So don't use it. Okay? Please, you need the practice. This will be 1/2. Right? That's the x and y coordinate. Tangent. Y over x, or sine over cosine. Root 3 over 2 over 1/2. You can simplify that without a calculator. So what does it come down to? Root 3. That's tight. Okay. Cosecant is the reciprocal of sine. And we can talk about rationalizing that. I'm just going to flip them for right now. See how you did on pi over 3. If you have questions about that, let me know. And then we can talk about the rationalizing in a minute. So don't worry about that right now. If you want to just write it down. So sometimes I like to do that, but it doesn't matter, so there's different ways. Okay? Awesome. Now, do you feel comfortable simplifying that?
No.
Okay, so you'll just multiply by the reciprocal. So, and I like the 1 over is great, but if it's a fraction, you can simply flip it for the reciprocal. But that one would be like this. So this is division, so it would be 1 times the reciprocal. Instead of 1 divided by root 3 over 2, it's 1 times 2 over root 3. Does that make sense?
Yeah.
Yeah. So the 1 divided by does just flip it for you. But sometimes, Dante, we do need the 1 over, so I like that you wrote it like that. But you can go straight to the other way. That, you know, if you're just giving them all. So that would be 2 over root 3, and then we can talk about the rational. So what would 1 over 1/2 be? leave that as 2. Yeah. Oh, yeah, right, yeah, 2. He's good. Okay. How you do what?
How do you do that?
Oh, I have to think. 3/2, 1/2, negative. Well, this one should be sine over cosine, so this over this.
Oh,
So I
well,
think you have it switched.
I think, well, I multiplied by the reciprocal, I think, then I got 2 over, well, let me think, I may.
Write it as a ratio so you can see it first, Federico, then maybe you can see it then you can maybe just remember it. But
Yeah.
I think the reciprocal helps.
Alright, makes sense.
This table makes my brain work harder. Now, I need to step back and look at those because I did them pretty fast. I think the pi over 3 looks okay. This one you would write as just 2 is fine. Okay. So this one we would rationalize, so we could say that's root 3 over 3. The 1 over root 3 rationalizes to that. So the one that's wonky is this one. Okay, so all I did for cosecant is take the reciprocal of sine. And the reciprocal is just flipping it. Okay, so what's that going to look like when I rationalize? 2 over root 3 is we're going to get rid of the square root of 3. So we're going to multiply root 3 over 3. So once you see these rationalized and you remember them, it's totally fine. We like that actually, you know. So root 3, oops, I'm sorry. Root 3, 2 root 3 over 3. Okay. So that's what happens when you reciprocate 2 over root 3. You get that. Okay, I'm sorry. Mine needs to be bigger. Okay. Do you have questions about any of the others? So this would be that same situation right there. It just takes a little practice and telling yourself sine is y, cosine is x, tangent is y over x, or sine over cosine.
A tangent would be the slope then.
Tangent is the slope,
So
yeah.
that's another way of remembering. 'Cause you
Yes.
just rise over run.
Tangent is rise over run. I love that. Yeah, we'll talk about that. Let's bring that back on Wednesday. Or what's today? Monday. Okay, so what I would like you to do is, if you want, I would recommend practice or fill in the rest of that and then check the answers. We will definitely do more unit circle stuff on Monday, okay, for practice. I do want to hit on a couple of these that are different. So how do you get these angles? Like 765 is not on the unit circle. Oh, and this is a bummer. I don't have my unit circle here, but that's okay. We can wing it. Oops. I need to zoom. Does that help? Ooh, that's not good. Well, maybe I can do this. Okay, that's better. Can you see that better? Okay, so 765 is not on the unit circle. Is there an angle that it's coterminal with that is on the unit circle? Okay, what would it be? Oh, is this the one we did earlier? No, it's not. Okay, so yeah, find the least coterminal angle. So that's going to be equal to the sine of 45 if you subtract 720, which is 2 360s, right? So I know it's going to have the same value. So what's the y-coordinate of the point at 45 degrees? Root 2 over 2. So if you did check in your calculator and you said sine of 765 and sine of 45, they should be equal, right? Okay, how about negative 120? Now, some people don't need to find a positive angle. They can find negative 120 and be good with that. Okay, so if you're okay with that, fine with me. If you want to find a coterminal angle, find the least positive one, what are you going to do? Add 360, which is going to be 240. So if I want secant, secant is the reciprocal of what function? Cosine. Now, you don't have to write this. I'm doing this more to make you think of it. It's 1 divided by the cosine of 240, or basically it's the reciprocal of the cosine of 240. So I don't expect you to do the 1 over. I like to write it like that because I'm practicing my reciprocal identities. So it's 1 over, what's the cosine of 240?
Negative.
We want the x coordinate. Cosine is the x. Negative 1/2. So 1 divided by negative 1/2 is 1 times the reciprocal, so it's going to be negative 2. Yeah, and it's 2 over 1, but we usually don't write the 1. Okay, so if you know the cosine, all you have to do is reciprocate it, flip it. Okay? All right. Ooh, let's do, how about cosecant of 11 pi over 3? So what is that's not on the unit circle, right? Because if I double 3, that's 6 pi over 3. That's 2 pi. So if it's bigger than double the denominator, it's outside of the unit circle. It's too big. So how are you going to find a coterminal angle?
Subtract 2 pi.
Subtract 2 pi. So here's your quick common denominator trick. It's fast, right? 11 pi over 3. 3 is the denominator. Double it. 6 pi over 3 is 2 pi. 6 divided by 3 is 2. You can get those fractions fast. Yeah. Question?
Will we have the unit circle on the
I'm sorry, I
We
can't
can fill
hear
it
you.
She said, will we have the unit circle on the exam?
You'll have a blank one that you're going to fill in, and then you'll use it. So you got to practice. That's why I'm spending so much time doing those patterns. So you have a way you have to practice it. I'll post a video too there's a video where they go through the memory things that you can re-watch as well. Trust me, once you start doing it, you get it. My students just crank it out left and right once you see the patterns of practice. Okay? It's new. You got to practice. Okay? So this becomes 5 pi over 3. So if I want the cosecant of 5 pi over 3, which coordinate do I need? The x or the y?
X.
Cosecant is the reciprocal of sine. So it's the 1 over the sine of 5 pi over 3, or the reciprocal. What's the sine of 5 pi over 3?
Negative root 3 over 2.
Negative root 3 over 2. It's the y coordinate. So it's 1 over negative root 3 over 2, or just flip it. I don't care that you put the 1 over, okay? I don't want you to have to do that. It's 2 over root 3, and then if we rationalize, it was -2 root 3 over 3, I believe. Okay. So it is a lot of stuff, but this is where we bring it all together, what we've been doing for a long time. Okay. So let's say tangent to pi over 6. Do you need to turn that into a positive coterminal angle? Maybe you do, maybe you don't. Hopefully you don't, because especially once you get better at it. So let's look back here. So instead of going pi over 6 positive, I would go pi over 6 negative. So this would be coterminal with negative pi over 6 would be coterminal with 11 pi over 6. Right? So if you're comfortable doing the negative, it's totally fine. As long as you can find the point on the unit circle that goes through the terminal side, happy. People will do it differently than other people. Okay, there's lots of ways. So then you're going to use, what was it, tangent? You're going to use the y and the x. Okay. Do you want me to write that in there, yes or no? Or do you want to do this? I like with tangent, I usually either write this or think about it when I'm first learning it, right? When you start knowing these like that, you won't need to write it. But you could say it's the sine of negative pi over 6 over the cosine of negative pi over 6, which is the y coordinate over the x coordinate, if you like the negative route. Otherwise, you'd have to find 11 pi over 6 and do it that way. Okay, so the sine is the y coordinate, which is -1/2. The cosine is the x coordinate, which is root 3 over 2. So that simplifies, get rid of the 2's to -1 over root 3. That's how I remember it, is that's why I like this better than the rationalized, because it tells me the 1 goes with the 1/2 and the root 3 goes with the root 3 over 2. Because to me, I'd rather not rationalize, but they do on this one. I didn't do any pi over 4's in here, darn it. That's okay. 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 So start practicing on that, okay? Questions? Do you want to go over anything else, or do you have any questions? We have time. I'm not going to rush us at the end. That's why I'm stopping a little early, because I'm usually rushing us.
Will
Federica.
there be any other study guides for the exam?
Yes, so let me summarize that right now, okay? All right, so for Monday, or before Monday, here's the things, and I'll post an announcement, but let's just talk it so you know it's gonna be there, okay? What do you need to do for Monday? Or before Monday, I should say. Before Monday. What? So if you haven't done day 4 homework in my math lab, which is applications of right triangles, finish that up, okay? When did I say I'd push that to? Friday? Friday? Sound good? Okay. Then what else should you do? You should work on definitely day 5. I would say day 5 and day 6. Day 6 is unit circle. Work on them, at least start on them. And then you're going to do what? Day 7 pre-work. And day 7 pre-work is, oh shoot, the first question, we didn't get to that. You can ignore question 1. I think it's question 1. Shoot. I'm sorry. Hold on. I gotta look at it. Oh, okay, write this down. Day 7 pre-work, unless you want to. If you're feeling all wild and crazy, you can do it. If you don't, I'm okay with it. You can omit numbers 1 and 2 because that was from today's 6, we didn't get to it. But we will do it on Monday. We'll review and we'll do that. Okay?
Day 6 almost due Wednesday.
Next Wednesday, yeah. I'm just saying work on it. I didn't say it was due. But if you wait until the very end to do all that, you're in trouble. So you need to get in there and do a little of each, even if you just do a little each day. 15, 30 minutes will be a good thing. I will post a study guide. I don't think we're done yet. Are we? This is basically practice for the exam. If you look at it, it's old stuff that you're practicing with. Okay?
Is that for the pre-work or is that not?
I'm sorry, what was the question?
This number 2 for pre-work.
No, homework is D2Ls, or My Math Lab, sorry. Homework is My Math Lab. Pre-work is pre-work. Homework is the My Math Lab, I just call that homework, because it's after class. We should call it post-class work. Okay, does that help?
Yeah, pre-work, post-work.
Pre-work is due before class, homework is due work on after class. Do as in work on. Okay. Other questions? Or any questions? Okay, lots of stuff. So do as much as you can to get caught up. Monday we'll spend time reviewing, but we will also do some new stuff on Monday. Okay? All right. Have a good day. Thank you.